Hello friends, I am Mr. Bharat Shelke, Assistant Professor working at MEP Samaj Arts, Science and Commerce College, Ozarmig, Nasik. In this video, I am going to explain the complex ions belonging to gravimetric analysis. Complex ion, the solubility, the ionic product and the dissociation factors we are going to explain in this video with suitable two examples. Now see the first, the meaning of complex ion. So complex ion means there is a combination of simple ions with opposite charge or with a neutral molecule. That means one cation combines with a anion and to form a ion, that is known as a complex ion. Now see the meaning. A complex ion is formed by the union of a simple ion with other ions of opposite charge or with neutral molecules. So simply there is a combination of ions of opposite charge, that is the meaning. Ions of opposite charge or with neutral molecules, and they form a ion, and that is known as complex ion. Now see the next most important sentence which we want to prove in this video. Formation of complex ion increase the solubility of sparingly soluble salt. Formation of complex ion increases the solubility of sparingly soluble salt. So that means when the complex ion is formed, and then the solubility of that salt goes on increasing. So when complex ion is formed, then the solubility product is increased as compared to the ionic product, and when it goes on increasing, then they gets dissolved. We know that when ionic product is greater than solubility product, then and only then precipitation is occur, because the solution is supersaturated. And when solubility product is greater than ionic product, then the solubility increases and precipitation does not occur. And in this case the same thing happens. That means when the complex ion form, then solubility product increases, and due to that the solubility of that complex ion goes on increasing. Now we will explain it with suitable examples. Now see the first example. When a solution of potassium cyanide is added to a solution of silver nitrate, then a white precipitate of silver cyanide is formed. So simply the addition of cation with AgNO3. See the reaction. Silver nitrate, that means Ag, cation means potassium cyanide. So the silver nitrate reacts with potassium cyanide, then they forms AgCN. So this downward arrow means formation of precipitate, and when the precipitate is formed, solid is formed, then we can write the arrow like this. So this is the AgCN, that means the precipitate is formed. Now when excess of cation is added, then a complex ion which is soluble in water is formed. So when excess of cation is added into this solution, that means this cation is added into this AgCN, then complex ion is formed, and when complex ion is formed, then the solubility product increases and then it goes into the solution. So initially the ionic product is greater, and when ionic product is greater, then precipitate is formed, but after the addition of excess of cation, the solubility product is greater, and when solubility product is greater, then this precipitate goes into the solution, or we can say this precipitate gets solubilized into the water. Now see the reaction. AgCN, that means this AgCN precipitating agent, this is the excess of cation, and when it is added into this AgCN, then they form a complex ion. This is the complex ion, and this complex ion is soluble in water, and then the dissociation changes. The complex ion dissociates in water to some extent. Now see how it dissociates. AgCN2 dissociates as Ag plus plus twice Cn minus. So it dissociates in some extent, and when it dissociates, then we can consider the dissociation constant. So what is the equation for dissociation constant? K is equal to Ag plus into Cn minus divided by AgCN2 minus. So this is the dissociation constant K, and we can write the dissociation constant equation like this. Now see, this dissociation constant value is very low. It is around 1 into 10 raised to minus 21 at a room temperature. So when the K value is low, that means the dissociation constant value is low, then the Ag plus value is also low. And if the Ag plus value is low, that means the solubility product value is greater as compared to the ionic product, and when it is greater, then it goes into the solution, and therefore solubility increases, and the precipitation compound is more soluble into the water, because this Ag plus concentration is low, and this low means solubility product is higher as compared to the ionic product, or we can say the solubility product does not exceeds by the ionic product. So from this equation we can say that formation of complex ion has increased the solubility. So formation of complex ion has increased the solubility but decreased the dissociation of complex ion. So we can define this statement by using this equation. So this is the first example for the complex ion. So when complex ion is formed, then initially a simple precipitating agent is formed, and when excess of KCl is added, then complex ion is formed, and the complex ion form increases the solubility and decreases the dissociation. Now see the different example, that is AgCl reacts with ammonia and they form a complex like this, AgNH3. Now the soluble complex dissociates in water to some extent. Now see the second example, that is the formation of a silver ammonia complex. Now see, the AgCl combines with ammonia, then the formation of this complex. So precipitate of silver chloride combines with ammonia, then there is a formation of complex in which the two oppositely charged ions are combined. Now the dissociation of this complex, this AgNH3 plus dissociates as Ag plus plus twice NH3 minus. Now this complex is soluble complex and it dissociates in some amount into the water, and it dissociates as Ag plus plus twice NH3 minus. Now see, the dissociation constant, or we can say the instability constant for this complex ion is K, and this instability constant or dissociation constant K is equal to this Ag plus, then NH3, then AgNH3 twice plus. So this is the undissociated, this Ag and this NH3 is dissociated form. So therefore K is equal to Ag plus NH3 divided by AgNH3 plus. So the dissociation constant value is 6.8 into 10 raised to minus 8. So this value is again lower, that means moderate value, not a very high value. So 6.8 into 10 raised to minus 8 is moderate. Then Ag plus value is again moderate, that means again it is a lower value. So when this is a moderate value or lower value, then the solubility product does not exceeds by ionic product, and if it does not exceeds by ionic product, that means the precipitate does not form and the complex ion goes into the solution and it is a more soluble into that water. So that means, see, the concentration of Pg plus is small, the formation of complex ion has increased the solubility and decreased the dissociation of complex ion. So when the complex ion is formed, then that complex ion dissolves into the water and his solubility is increased into the water, and due to the increase in solubility, it dissociation of that complex ion is again decreased. So this is the effect of complex ion. So in this way the complex ion affects on solubility because it affects on the solubility product and ionic product, and therefore the maximum amount of complex ion gets dissolved into the water. So these are some two examples by which I explain the solubilization or the increase in solubility of complex ion. So in this video we discuss the formation of complex ion, that means there is a combination of different charged ions or simple ions with oppositely charged or with neutral molecules. Then the solubility is increased and again the dissociation decrease. So this is about the complex ion. So thank you for watching this video.